Simplifying and expanding fractions. This set of videos explains the why behind, the reason for simplifying, also known as reducing, and expanding fractions, basically explaining the why behind for AC over BC is equal to A over B, where A is any real number, B is any real number but 0, and C is any real number but 0. I would now like to share my outline so that you can know what I'll be talking about and in what order. So first is the introduction. First is the overview, which was the previous slide. Then is the outline, which we're going over right now. And then we'll be talking about the use of simplifying fractions. Why would I want to simplify fractions in the first place? Then we'll be talking about the use of expanding fractions. Why would I want to expand fractions in the first place? And then we'll be talking about simplifying versus expanding. Basically, I'll be explaining that if I show the why behind for simplifying fractions, I'm also showing the why behind for expanding fractions. Then I'll be using a visual to explain the why behind for simplifying fractions, where A, the numerator is a positive integer, B, the denominator is a positive integer, and C, the multiplier or divider based on if you're expanding or simplifying fractions is a positive integer. So the first material we use to talk about this visual is a cracker, and I'll be using this cracker to explain that 2/6 is equal to 1/3. The next material we use for this visual is pizza, and I'll be using this material of pizza to explain that 12/20 is equal to 3/5. Then I'll be talking about when you include negative numbers. So first I'll be talking about when you have a positive numerator, a positive denominator, and the multiplier or divider is negative. Then I'll be talking about when you have a negative numerator and a positive denominator, and we'll be going over both of the cases where the multiplier or divider is positive or negative. Then a positive numerator and a negative denominator, and we'll be talking about both of those cases where the multiplier or divider is positive or negative. And then a negative numerator and a negative denominator, and we're talking about both of those cases where the multiplier or divider is positive or negative. Then we'll be talking about when you include 0. So first we'll be talking about the numerator as 0, or A as 0. Then we'll be talking about the denominator as 0, or B as 0. And then we'll be talking about the multiplier as 0, or C as 0 when you're expanding the fraction. Then we'll be talking about the divider as 0, or C is equal to 0 when you're simplifying the fraction. So far to explain this idea of simplifying or expanding fractions, we first use a visual to explain this idea where A, B, and C are positive integers. And then, using this information we learned that simplifying and expanding fractions works where A, B, and C are positive integers, we then talked about including negative numbers. So because we only use the information of positive integers, when we now include negative numbers, we're only including negative integers. So from there, we knew it worked from negative or positive integers. And then we talked about including 0. So we only talked about where A, B, and C are integers. But there are other ways to explain this idea of simplifying and expanding fractions. And they do not depend on the idea of A, B, and C of being integers. So here are other ways to explain this idea of simplifying or expanding fractions. So I go over way number 2, way number 3, and then way number 4 to explain this idea. So why would you want to simplify, also known as reduce, fractions in the first place? One reason is that it is often nice to have the final answer written in the least complicated or most simplified way. For example, when solving 4 times 5, it makes more sense for your final answer to be written as 20 rather than as 4 plus 4 plus 4 plus 4 plus 4. Both of these are correct, but 20 is more simplified. Likewise, when solving 3/20 plus 9/20, it makes more sense for the final answer to be written as 3/5 rather than 12/20. Both of these are correct, but 3/5 is more simplified. Now, why would you want to expand fractions in the first place? One reason is to add fractions of unlike denominators. You cannot add fractions of unlike denominators in their current state. I explained why this is the case in a previous set of videos called Adding and Subtracting Fractions, and hopefully the link to that previous set of videos is in the description of this video. To add such fractions of unlike denominators, you must make the denominators the same. To do this, you expand the fractions. For example, what is 1/6 plus 3/4? Well, I can multiply both the numerator and denominator of 1/6 by 2 and both the numerator and denominator of 3/4 by 3. Now, this is equal to 2/12 plus 9/12. To add fractions, you add the numerators but keep the denominators the same, and that is 11/12. So how we added these two fractions of unlike denominators is we expanded the fractions to have like denominators, and then we added them up. Let's now talk about examples for simplifying fractions, also known as reducing fractions, and let's also talk about examples for expanding fractions. For both of these types of concepts, let's talk about it without algebra and then with algebra. Let's simplify 12/20. To do so, let's divide both the numerator and denominator by 4. And so that would be 3/5. To expand 3/5, we can multiply both the numerator and denominator by 4, and we end up with 12/20. So simplifying fractions is the exact opposite as expanding fractions. Simplifying fractions goes in one direction, and expanding fractions goes in the exact opposite direction. So what this means is that if I explain the why behind for simplifying fractions, I'm also explaining the why behind for expanding fractions. Let's now talk about these ideas by using algebra. AC over BC. We can divide both the numerator and denominator by C, and we end up with A over B. To expand A over B, we can multiply both the numerator and denominator by C. Now, A times C is normally written as AC, and B times C is normally written as BC. So simplifying fractions is the exact opposite as expanding fractions. Simplifying fractions goes in one direction, and expanding fractions goes in the exact opposite direction. So what this means is that if I explain the why behind for simplifying fractions, I'm also explaining the why behind for expanding fractions. Thank you for watching this video. Here is a link to the playlist about simplifying and expanding fractions, in which this video is a part of. Feel free to click on this link.